Thank you, Jean, for the invitation. As always, very thoughtful and useful events what you organize. My name is Rodrigo Belisario. I'm the Alternative Fuels and Raw Materials Director for Titan, Florida. And let me quickly start by presenting a company. Titan Cement, Titan America and Titan Florida are part of a Titan Cement group, which is a European cement producer based in Greece. In Florida, you might have seen our plant next to the Turnpike in Miami or our ready-mix trucks across the state. We have the largest cement plant in Florida. Was more than 2.3 million tons per year of cement produced. We have been producing engineered fuel from recovered resources since mid-2000s, growing every year after years. And a couple of years ago, we commissioned finally a $25 million investment for producing our own alternative fuels out of different waste streams in the area, no? And as of late last year, we were able to reach a 30% substitution rate, replacing roughly 100,000 tons per year of coal, enough energy for 100,000 homes. No? This is if you can compare, and the process for making cement is very, very energy intensive. So 30% of substitution is a tremendous amount of energy that is not coming anymore from fossil fuels and more from waste that otherwise would end up in a landfill. No? We're proud to say that we have one of the most aggressive sustainability goals of all the cement companies in general, and definitely from Florida cement companies. Let me try to explain a little bit how the cement process works. And basically, if you can see my cursor here, and we extract, or we bring from our different quarries and limestone and clay, basically, and it's crushed to around 3 inches size and mixed with different materials, iron, silica, alumina, and then all that is grinded to a very, very fine powder. That is what we call the raw meal. This raw meal, this very fine powder, is introduced to this preheating tower, and where it begin a transformation process. First, losing the water, they dehydrate it and transform the limestone into lime. And as it goes through the process, coming down from this preheater tower and through this rotary kiln here, it keeps transforming into basically melting lava at the highest point here. No, at this point, the limestone that has been turned into lime around here is turning into what we call clinker. Okay, the temperatures on this process in this little tube here that is not so little at all, and goes from 2800 here at the highest point to probably 600 here at the beginning of the process. No, after that, the clinker, which is some little black balls about an inch and a half diameter, are quickly cooled down with air, grinded with gypsum, limestone, or other products, and that is what at the end is you see in a cement bag, and is poured into concrete in the driveways and the buildings and everything. Okay, and so why cement? Why is cement plants? And we have been hearing in all the presentations that TDF is a great solution, and the cement plants are one of the biggest users of the tire-derived fuel. No, first, and the long residence times, very high temperatures and long time can guarantee the complete destruction of any organic compound that might become in the different waste streams that we use as a fuel. And the combustion happens in an environment rich in oxygen and active lime, which means that we can ensure enough oxygen for the combustion and neutralize the gases generated during that combustion process, meaning the SOx and the hydrogen chloride. Okay. And one of the most important and unique about the cement kilns is that the ash that is generated by the combustion of the different fuels and the different material is incorporated into the clinker's crystalline structure, meaning everything that comes out as a fuel and as a raw material is turned into a product. So there is no ash generated that has to be disposed in a landfill later on. And because it's entrapped into the crystalline structure of the clinker, there is no leaching out of the material. Okay, here you can see a little bit a side view of the process and the temperatures and the different materials and rest temperatures that during the process. No, how we control that? Well, we're doing it in the right way. We have, on top of the quality control of our final product, we still make cement for a living, and we have 24/7 continuous monitoring of our emissions, and where we measure all these parameters now: CO, CO2, volatile organic compounds, Cl and OX, mercury, dust, temperature. Okay, and now I said 2 years ago we finally commissioned a plant with a $25 million investment. It's a state-of-the-art facility, probably the largest and most modern in all country, for the sustainable production of PEF, of process engineered fuel. This process line contains a primary and a secondary shredder, ferrous and non-ferrous separation, and wind shifter, adjustment bunkers, optical scanners for quality control. So we measure the moisture and the chlorine content and the calorific value of all the material that is produced out of this plant. It's a 24/7 operation, automated, completely automated. And because of all this, we can offer a competitive prices versus other disposal solutions, basically versus landfills and others. No, this plant has a 150,000 plus tons per year production capacity, and currently, right now, we are processing around 2,400 tons per month of tire-derived fuel, and up to 12 tons per hour convenient feeding capacity, meaning TDF and other engineered fuel that we produce out of this plant. We can go now up to 12 tons per hour, and we are in the plans of improving, actually tripling our processing, our feeding capacity into the kiln. Okay. Now, what are the different materials or waste streams that can be transformed into engineered fuel? Okay. Pre-sorted urethane debris is something that Florida we have discussed with Gene and some others in Florida. That is something that we can help with. And commercial, industrial, off-spec materials, C&D material, wood, plastics, textile materials that regularly go to a landfill. And plastics are very good for us, something as long as it doesn't contain PVC. And agricultural biogenics, biomass, the TDF, the tire-derived fuel, which is the subject of this. And we have some technical constraints, limitation. We process it at 2 inches minus wire-free material. And in general, any recycling residue, what is rejected from the different MRFs or that is not recyclable by the different recycling companies in the state, is something that we use also as a feedstock to produce at the end engineered fuel. At the end, all these streams are shredded except for the TDF that is fed separately into the kiln. All these other streams are shredded together and produce an engineered fuel that is basically a fluff, a confetti of all this material that is blown into the kiln at 12 tons per hour. Okay. And I didn't want to take too much time and leave more space for the discussion that is very relevant. But if you have any question, feel free to reach out.